Sodium azide decompose into its element. So basically the chemical equation is like this. You have NaN3, right? Decompose into its elements. What are the elements here? Must be the Na, must be the N. And then it says that required to produce nitrogen. So this one must be the nitrogen gas, N2. Okay? So from here you can try to balance the chemical equation. So I have, okay, so this one is 3, 2, right? So 3, 2. And then you have 6 nitrogen here, 6 nitrogen here, and then 2 sodium, 2 sodium. So this would be the chemical equation. Now what is the mass of sodium azide? So what is the mass required to produce 48 dm cube, 48 dm cube of nitrogen? Okay, so you basically just need to look at this 2 mole ratio. So mole ratio, so what is the mole ratio between NaN3 as well as N2? So according to the chemical equation, it is 2 mole reacts with 3 mole. 2 mole reacts with 3 mole. So now you have 48 dm cube. 48 dm cube is how many mole? This is a gas, right? So 1 mole of any gas occupy 24 dm cube. 48, that will be 2 mole. 2 mole. So 2 would be 2 over 3 times 2, which is 4 over 3. So you have 4 over 3 mole of sodium azide. So what would be the mass? So the mass would be the mole, which is 4 over 3, times the MR for sodium azide, which is 23 plus 14 times 3. And if you work it out, the answer would be 86.7 gram. Okay, so the answer is B. Okay, 14. Which solution has the greatest number of chloride ion? Chloride ion. So this is calcium chloride, CaCl2, iron 2 chloride, iron 3 chloride, FeCl3, dilute hydrochloric acid, HCl, aqueous chlorine. Aqueous chlorine is basically in a simple molecule form. So this one, there is no chloride ion. Chloride ion is Cl minus. Okay, so over here, how many mole of calcium chloride? So when you multiply these two numbers, you get the number of mole. So you have 1 mole of calcium chloride here. How many mole of iron 3 chloride? 1 mole also, because 1 dm cube times 1 mole per dm cube. How about here? HCl, you have 2 mole. Greatest number of chloride ion. 1 mole of calcium chloride. How many mole of ion? How many mole of chloride ion? 2 mole. This one, 1 mole of iron 3 chloride. 3 mole Cl3, right? So 3 mole of chloride ion. This one would be 2 mole of chloride ion. So the answer is B. So just remember FeCl3, okay, basically consists of 1 mole of Fe3 plus ion and 3 mole of chloride ion. Okay, 3 mole of chloride ion. This one, calcium chloride, 1 mole. Hydrochloric acid, 2 mole. Okay, number 15. In experiment, 5 cm cube of 1 mole per dm cube sulfuric acid is added to 5 cm cube 1 mole per dm cube sodium hydroxide containing universal indicator. Which change occurs in the mixture? Okay, so this sulfuric acid H2SO4, it consists of H plus ion, sulfate ion. This one, sodium hydroxide, Na plus, OH minus. So when you, now this one is a dibasic, okay? So when you pour your sulfuric acid into it, then the hydrogen ion will neutralize the hydroxide ion. Hydrogen ion neutralize the hydroxide ion. But since this one is dibasic, there will be excess of hydrogen ion. Okay, there will be excess of hydrogen ion. So meaning that the concentration of hydrogen ion will increase. So it's B. Number 16, which ionic equation shows the reaction between sodium carbonate and dilute nitric acid? So you can write down the chemical equation, sodium carbonate, okay, this is AQ, soluble, HNO3, AQ, acid carbonate, you get salt, NaNO3, plus carbon dioxide, which is a gas, plus water, which is a liquid. And then you try to balance it. You balance it, Na2, right? So 2, and then after that 2H, so 2. Okay, and then you try to, so for all the aqueous, you break it into its ions. So you get 2Na plus CO3 2 minus plus 2H plus 2NO3 minus 2Na plus 2NO3 minus plus gas remain as it is, it doesn't ionize, water as well. Then you cancel off the spectator ion, which are the ions that are the same on both sides of the chemical equation. So what is left is this one as the reactant, these two as the product. So the answer is A. Okay, number 17. Which reaction is the metal oxide or metal hydroxide not behaving as a base? So which means they have to recall what are the reactions involving base. So you have acid plus base, you get salt and water. Okay, any other reaction that involve base? You have ammonium salt plus base will give you ammonia, salt plus water. Okay, these two reactions that involve base. Okay, let's look at the first one. You have acid, okay, base, acid, you get salt and water. Yes, so the first one, the metal oxide does behave as a base. How about the second the second option, B? You have ammonium salt, a base, you get salt, ammonia and water. Yes, it does behave as a base. How about the third one? Ammonium salt again, base to form salt, ammonia and water again. So the answer must be D. If you look at the answer, acid and the base, so this is a metal oxide, right? If it is a base, it should give you salt, water and carbon dioxide, but this is not carbon dioxide. So in this case, the metal oxide does not behave like a base. Number 18, which statement correctly describes the difference between strong acid and weak acid? So strong acid must ionize completely in the water to form H plus ions as well as whatever negative ions it is. And then weak acids, weak acid should produce a low concentration of H plus ion as well as the negative ion. So in this case, the answer is B, because strong acid conduct electricity better than weak acid solution because it has more ions, more hydrogen ions, more negative ions. Number 19, powdered calcium oxide is commonly placed near chimneys in coal-burning power stations to reduce atmospheric pollution. So this one is from the atmosphere chapter, air and atmosphere chapter, by removing waste gases. Which gas will not be removed by the powdered calcium oxide? Powdered calcium oxide. Now, this one is a base. It is basic. This one, neutral. Carbon monoxide is a neutral oxide. So neutral oxide will not react with a basic oxide. So the answer is A. How about nitrogen dioxide? This one is acidic. Phosphorus 5 oxide is also acidic because and sulfur dioxide is also acidic. All these are non-metal oxide, they are all acidic. Carbon monoxide is a neutral oxide. This is from the acid bases chapter. So this question basically, though it sounds like in the atmosphere and environment chapter, actually is talking about the types of oxide, which is in acid bases chapter. Okay, number 20. Which reagent could be used to distinguish between dilute nitric acid and dilute hydrochloric acid? Barium chloride. Now, barium chloride, you add it to nitric acid, there is no visible reaction. How about barium chloride and dilute hydrochloric acid? This one also no reaction because chloride. How about silver nitrate? Silver nitrate with dilute nitric acid, no reaction. Silver nitrate, dilute hydrochloric acid, because dilute hydrochloric acid has chloride ion. Now, when chloride ion will combine with a silver ion to form silver nitrate, because this silver, to form silver chloride, because this silver chloride is a white precipitate. Okay, so when you add silver nitrate to dilute hydrochloric acid, there will be a white precipitate. Silver nitrate, dilute nitric acid, there will not be any visible reaction. So we can use silver nitrate to distinguish these two acids. Number 21. Which reagents are suitable for the preparation of aqueous sodium sulfate? Aqueous sodium sulfate. Now, sodium sulfate, you know that it is a spa salt. Okay, so how about the first one? Sulfuric acid and carbonate. So acid and carbonate, you should get sodium, you should get salt, water and carbon dioxide, and in this case you should get sodium sulfate. Okay, so the answer is A. Now if you look at B, sodium carbonate, barium sulfate, this one is a solid. So this one there won't be any reaction. Sulfate and carbonate, no reaction. How about C? Sodium nitrate and aqueous lithium sulfate. Also this one no reaction. Okay, and then sodium and dilute sulfuric acid. Actually this one is acid and metal. You should get salt and hydrogen. You should get sodium sulfate and hydrogen. But this one, it is not feasible because the reaction is too explosive. Alright, so this one 21, it is not a feasible reaction because you cannot add such a reactive metal into acid. There will be explosion. So even though theoretically it would give you sodium sulfate, but it is not feasible. That's for D. Okay, number 22, a green solid M react with, so you have M, green solid, react with hydrochloric acid to form a green solution plus a colorless gas. The gas form a white precipitate with calcium hydroxide. So this colorless gas, I add calcium hydroxide. Now this calcium hydroxide, remember, it is lime water. It is actually a lime water. You add this, you get a white precipitate. White precipitate, which is your calcium carbonate. The green solution, see, the green solution reacts. So this green solution reacts with potassium hydroxide to form a blue precipitate. You see, this blue precipitate, see this one has hydroxide, right? So this blue precipitate, very likely it's copper 2 hydroxide. This blue precipitate. So if this blue precipitate is copper 2 hydroxide, the copper must have come from this green solution. So this green solution would be, and then this one is there is a chloride here, right? So this green solution will be copper 2 chloride. If this green solution is copper 2 chloride, this one must be, you see, you have carbon dioxide, salt carbon dioxide. So which means that this one must be copper 2 carbonate. So it is A. So quite a complicated question, but if you write it down like this, that would be quite easy. Okay, number 23. Qualitative analysis. Solution P is added gradually to solution Q followed by the addition of dilute acid R. The graph shows how the mass of precipitate changes as the reagents are added. So you have Q, so you add P slowly, you add P gradually, followed by acid R, okay, followed by acid R. Which set of results could be deduced? So when I add P, the precipitate gets more and more. And then as soon as I add acid, the amount of precipitate decreases, which means that this acid must react with the precipitate, must react with some of the precipitate, not all the precipitate. So if you look at A, barium chloride is P, and then your Q is carbonate ion. So when you add barium chloride to carbonate ion, then it would barium carbonate. Barium carbonate is a precipitate, so it's correct. Precipitate increases. When I add acid, it should react with all the precipitate because carbonate and acid does react. So this precipitate will actually should decrease all the way down. It doesn't just decrease a bit, then after that the amount of precipitate stay constant. So which means that the anion in Q is not only carbonate, it's probably carbonate and something else. Okay, so if you look at B, barium chloride again, and then the anion is chloride and carbonate. So when you have this situation, you have barium chloride. Barium chloride is not a precipitate, so barium carbonate. So same thing, you have a lot of precipitate, okay, precipitate form, and then when you add R, so the precipitate in this case would be only barium carbonate. So if you add acid reacts with barium carbonate, so the mass of the precipitate should go down all the way. It should not go down a bit then stop. Okay, so B is not. Now if you look at C, silver nitrate. Now silver nitrate, if I add these two, so what do I get? I get silver chloride as well as silver carbonate. Both are precipitate. So you have two types of precipitate here. Alright, then I add nitric acid. This nitric acid will only react with silver carbonate, acid and carbonate. Okay, it will react with this, but nitric acid will not react with this silver chloride. That is why the precipitate amount of the precipitate decreases a bit, then after that stay constant. So stay constant meaning that here the precipitate that remains after you add the nitric acid would be the silver chloride. So the silver carbonate would have already reacted with dilute nitric acid. So there are two types of precipitate here. Okay, so the answer is C. Difficult question. Number 24. Chlorine reacts with sodium hydroxide according to the equation. Which statement correctly describes what happens during the reaction? So you have Cl2. So Cl2, what is the oxidation state? The oxidation state of chlorine in Cl2 is 0. Oxidation state of Cl here, -1, because this guy here is Na plus and Cl minus. Now how about this? This one, if you split it, it is Na plus and ClO minus. Correct? One is plus, one is minus. So when you combine together, it's NaClO. Then this ClO minus can be further split. O must be 2 minus. So which means that this minus is the oxidation state for the entire ClO. So which means that this Cl, the charge must be plus. Because 1 plus 2 minus, the net charge is negative. So the oxidation state of Cl in NaClO is plus 1. So meaning that Cl is reduced and is also oxidized. Okay, from 0 to -1 is reduced, right? From 0 to +1, it's oxidized. So the answer is C. 25. Which reaction is the underlying substance acting as an oxidizing agent? So you have iron 2 chloride. Iron 2 is Fe2 plus, chloride Cl minus. This is Fe3 plus, Cl minus. So the oxidizing agent must be chlorine, because chlorine oxidizes the Fe2 plus to Fe3 plus. Answer is A. Okay, number 26. Brass is an alloy of copper and zinc. Which statement is true about brass? It can be represented by the chemical formula. You cannot represent mixture by a chemical formula. And then it is formed by chemical reaction between copper and zinc. No, there is no chemical reaction. Okay, mixture, no chemical reaction. It reacts with aqueous sodium hydroxide to form a blue and white precipitate. Now, in order for a substance to form a blue precipitate with sodium hydroxide, you must have CO2 plus. Okay, CO2 plus. There is no CO2 plus here. There is Cu. Copper to ion and copper are totally different. And then likewise for white precipitate, if you have zinc 2 plus, Zn2 plus, yes, react with the sodium hydroxide will give you zinc hydroxide, which is a white precipitate. So C is wrong. And then how about D? Zinc in the alloy will react with dilute hydrochloric acid, correct? Because zinc is a reactive metal, react with acid to form salt and hydrogen. Number 7, 3 metals, blah blah blah, transported. So you have barium, cerium and dium. Dium does not react with water, so which means that dium is the least reactive. And then when cerium is dropped into aqueous barium sulfate, barium is not displaced. So barium is not displaced, meaning that barium is more reactive than cerium. So barium most reactive, cerium second, least reactive is dium. So increasing order, dium, cerium, barium. Which metal carbonate cannot be decomposed thermally? Now, so this one is from the metals chapter. So all metal carbonates can be decomposed except, so all metal carbonates can be decomposed thermally, okay, or by heat, except potassium carbonate, sodium carbonate. These two you heat until next year, so it will not decompose. So like for example calcium carbonate. So calcium carbonate, if you heat it, you get calcium oxide and carbon dioxide. But these two, potassium and sodium, they are the most reactive metals in the reactivity series. So they will not decompose by heat. So the answer is C. Okay, 29. Diagram shows experimental setups to investigate the sacrificial protection of iron. So sacrificial protection of iron. So which beaker with the iron nail rust first? So this one, sacrificial protection, because magnesium is more reactive than iron. So magnesium will corrode first in place of iron. Same thing, zinc will corrode in place of iron. But this one, iron is more reactive than copper. So iron will corrode or will rust first. So X, iron nail rust first. Number 30. Now this one is electrolysis. You haven't learned yet. 31. Also electrolysis. You haven't learned yet. 32. Also electrolysis. You haven't learned yet. Okay, how about 33? Rhenium, Re, is in the same group as manganese in the periodic table. What is the formula of potassium? You see here, manganese. So you try to recall any manganese that you have learned. And then you have potassium rhenate 7. Isn't it very similar to potassium manganate 7. Now the metal is manganese. When it becomes a negative ion, the name will change. Alright? Just like sulfur becomes sulfide, oxygen become oxide. Yeah, so it is very similar. So if you see some metal that you don't recognize, you try to recall anything similar in the syllabus that you have learned. Okay, potassium manganate 7. What is the chemical formula? KMnO4. So since this rhenium is in the same group as the manganese, so it would behave similarly to manganese, meaning that the chemical formula would be K. In this case is rhenium, right? Rhenium O4, which is C. Which is A. Okay, something similar in the syllabus. Try to recall. Same group, same chemical properties. 34. Okay, blah blah blah. Flowing steps shows the conversion of this to carbon dioxide and water. So which of these are endothermic? Now, first of all, what is this? Okay, CO2, water. You get CO. Okay, gas, liquid. Okay, see two gases. This one carbon dioxide gas. This is water vapor. This is water. So water vapor has more. Water vapor molecules are more energetic compared to liquid water molecules. Okay, so you have more energy to become less energy, meaning that it is exothermic. Energy is given out. So this is exothermic. How about this? This is actually, you see, combined with oxygen, and then you get carbon dioxide and water vapor. So this is combustion. Combustion must be exo. And then after that, you have liquid to gas. Exactly the same substance, liquid to gas. Liquid particles, less energy compared to gas particles. So you have less energy, more energy. So you must absorb energy. Then endo. Less to more, you must absorb energy. Same thing. Less energy, more energy. Less to more, you must absorb the energy. So it's endo. So the answer is A. 34, it's A. Okay, next question is on energy profile, energy changes. Okay, you have with and without a catalyst present, meaning that this one must be without catalyst. This one must be without catalyst, because catalyst can lower the activation energy, and this one must be with catalyst. Which option represents the activation energy of the uncatalyzed reverse reaction? That means from the product to the reactants. Uncatalyzed. So uncatalyzed, look at this. Reverse reaction, meaning that from the product to the reactant. So from the product, you need to climb this mountain. Then only the product will react to become the reactants. So this is the mountain that you have to climb. So basically this is the activation energy. This is the energy barrier that the product particles must overcome in order for the reactants to form. So it is B. 36. The fuel produces the least energy when 1 gram of the compound is completely burned. Now this one is kilojoule per mole. How do you change it to mass? Okay, what is the mass of 1 mole? A mass of 1 mole is basically the MR. Okay, remember the triangle? You have mass, mole, MR. Okay, if I want to find the mass, it must be the mole times the MR. So the mole in this case, this is per mole, right? So this is 1 mole. 1 times 16, that would be the mass. So if I want to find the energy per 1 gram, I must divide this by the MR. So divide this by 46, divide this by 44, divide this by 100 and then find out what is the answer. So if you go and calculate out, you get this 55, 30, 50, 48. Okay? So produces the least energy, that would be B. Because 30 kilojoule per gram. So this one would be 30 kilojoule per gram. Okay, number 37. Powdered. You have powdered. Okay? So how long did it take to fill the gas range in this experiment? Okay, this one is powdered. Powdered takes 36 seconds. So if I use marble chips, which is large particle size, which means that the reaction will be slower. So there is only one answer here, which is longer than 36 seconds, which is D, 72 seconds. Okay, how about 38? 38, two experiments were carried out at 30 degrees Celsius. In experiment 1, 25 cm3 of hydrochloric acid, blah, blah, blah. So, you can see that excess calcium carbonate, which means that your hydrochloric acid is a limiting reactant. So, limiting reactant, what is the number of mole of HCl? Which is 25 over 1000. Okay, change it to dm cube first. Times 0.75. So you get 0.01875. Okay, the volume of carbon dioxide collected, okay, experiment 2 was doubled. Okay, so when the product is doubled, it means that the limiting reactant must be doubled. Okay, because the amount of product, so amount of product depends on amount of limiting reactant. When the product is doubled, it means that the limiting reactant must be doubled. Yeah, so the answer is B. Why? Because B, if you calculate out, the number of mole of HCl is 1.5 times 25 over 1000, and the answer is 0.0375, which is doubled of 0.01875. Okay. Alright, 39 should not be a problem. 39. Okay, other gases. So this one I don't think I need to explain much. How about for 40? 40 process does not increase the amount of carbon. Combustion of fuel, yes, produces carbon dioxide. Decay, this one also produces carbon dioxide. Respiration also. But photosynthesis actually use carbon dioxide. So it doesn't increase the amount of carbon in the atmosphere. So the answer is C. Okay, that's all. Thank you. Remember to write down all the working. Must work hard, huh?